everyone. So I'm really excited to be here today, and I was just listening to Stephen talking about all these great technology innovations that are out there today and how little I think people know about them. I've been listening in some of the breakouts and so forth, and to quote William Gibson, who's a famous author, the future's already here, it's just not evenly distributed. And I think there's a lot of power in what we can do to apply all of these new adjacent technologies to our businesses and our problems. And so as I give my talk today, I'd really like to encourage you to think about a question that you might have for your business and maybe how you might apply this, because I think it's a really important thing to think about our business challenges, not technology first, and to put those challenges really at the paramount of what we want to do and how we apply these new solutions. We need a new way to fuel our ideas into the future. And so with that, so fuel has always been an accelerant for how we take our ideas and make them real. Coal accelerated and for how our ideas could go from handmade to machine-made. And this propelled us and our ideas into the industrial age, the age of steam and steel. And from here, we made real our ideas. For the telegraphs and railway networks, gas and water supply, electrical power and telephones, we'd taken our first step into today's connected age. And the fuel for this journey? Oil. Oil sparked an unprecedented boom, and regulators scrambled to control its rapid growth. Now, does any of this sound familiar? The fight over a new commodity, fast, unregulated growth? Well, if it does, it's because we've discovered a new fuel for our ideas: data. Data is the new commodity being fought over today, and the cloud is its pipeline. Data is the fuel that drives the 5 biggest companies in the world, all of them cloud companies. For Google, Amazon, Facebook, Apple, and Microsoft, the cloud is the new baseline, and it's the cloud that's transforming the way all of us live our lives today. The way we travel, the way we relax, the way we communicate. Software is eating the world, and the world of design is undergoing the same transformation. You see, the cloud is already transforming the way each of us design and make things. And as we let go of our design tools and we hand more control to intelligent algorithms, we'll see this reflected in the real world. The world of self-driving everything. Abundant computing and artificial intelligence is going to profoundly change our tools as well as what you would expect from them. Now, let me show you what I mean. Now, let's start by looking at how our design tools are being transformed by abundant computing power. This is the VanWinen 12 plant in Norway. It's the country's largest river hydropower station, and it's set a new standard for infrastructure and construction projects. Norconsult, the company brought in to modernize the century-old plant, sought to use BIM throughout the entire project, right the way from conceptual design to construction. They challenged the old ways of thinking, and they pushed the limits of technology. Now, Norconsult also used computational design, here to adjust and place steel reinforcement into the complex concrete parts of the structure, such as this turbine that you see here. Now, the team used drones on site, as well as reality capture, to make sure that the existing structures merged seamlessly with the new. They referred to the BIM model on tablets, on site for QA, and to spot potential problems before they ever became real problems. Now, Norconsult were able to use this technology to dramatically influence and change how power plants of tomorrow will be built. And that's the state of the art today for the engineers and contractors who build incredibly big solutions to incredibly big problems. But I have to confess, there's a problem with all of this. All of this starts with this. No matter how big our ideas, we still have to push them onto our computers. The architects of the world still have to design the built world using tools that they need to direct. You still need to draw the lines and arcs and circles to describe your idea. But this is changing. Now that computation is abundant, we can flip the very way that we design around. Now let me tell you a story about our team in Toronto. They moved into a new building, and so we're using it as a living experiment. An experiment to discover how we could maximize productivity while creating a great environment for all of the people working there. So we used a form of computational design. We call it generative design. And we fed it the forces influencing human productivity. We surveyed our employees, and we captured their preferences and their work habits. So the system then evaluated that survey data against a set of hard constraints, such as the boundaries of the building, the fixed locations of the stairwells, and so forth. And then it generated thousands of alternative floor plans, all in the time it would take us to draw just one. The system sought to minimize distractions, to maximize outside views, and to prioritize personal relationships. Ultimately, to find an equitable solution to everyone's needs. And we weren't just pushing cubicles around like Lego blocks. And we weren't just stuck with the first floor plan that worked. While our traditional design tools passively awaited our instruction, the relationship was purely directive. We directed the tool. But this relationship has evolved into one that's adaptive. Our generative design tools now can anticipate our needs, and in doing so, help us discover the best design possible. But exploring office layout is just one step on a bigger journey. You see, office layout isn't too dissimilar to factory layout, and that's where we're heading. So just imagine what generative design could do to make our factories more adaptive. Now what you see here is a fully simulated factory. Everything from the robots, machine, equipment, parts, even the forklifts running around. But unlike an animation from a game or a movie where you'd have a hard time telling if this factory actually operated like the real factory, this is a true industrial physics simulation in full-scale VR. A real factory operating virtually as if it was already there. And how about making the things we design? Well, let's look at the way we construct things and how this is being transformed also by abundant computing power. So we're starting to see robots move off the production line onto the construction site. But the work that they're doing there is every bit as repetitive. And we think we can flip this on its head too. Our robots can do much more. Let me show you what I mean. So this is Ash. Ash is no different than any other robot, except we don't give her repetitive work to do. Instead, we're exploring how we can give Ash more freedom. Freedom to 3D print and metal all on her own. Ash doesn't rely on us for direction. Instead, Ash works as part of a closed-loop system to self-correct as she prints. Now, we've been working with a team at MX3D, and they've been helping us to push this envelope a lot further. We've been working with MX3D to robotically print this bridge. Now, it looks easy, but it's not. You can't just 3D print in steel like you can with plastic. Simply applying one layer after the next isn't always going to work. If the robot welds on top of a layer that's only recently been applied, the weld is weakened. So the robots in MX3D have sensors that track how hot every bit of metal printed is. And a machine learning algorithm helps the robot learn how to adapt its welding strategy on the fly. So the robot has the capacity to spot potential problems before they ever become real problems. And as we build more flexibility into the capabilities of our robots, we need to build more flexibility in how we work together. And by bringing our robots into full-scale, real-time virtual reality environments, we can step into their world and enjoy a closer relationship. We can interact with them intuitively, and we can use our arms to manipulate theirs. We can learn how to work better with them. And thanks to the machine learning and abundant computing power, they can learn how to work better with us too. So the way we work with robots no longer has to be so rigid, thanks to VR. And by giving our robots new capabilities, the way we work with them can be more fluid. And so with more fluid and adaptive tools, both digital and physical at our disposal, what might a typical design build job start to look like? Well, we're exploring this question with one of our customers. VanWinen is a family business in the Netherlands, and they employ about 1,700 people, and they build a lot of property. Now, including zero-energy affordable housing like you see here. Now, zero-energy affordable housing may seem paradoxical to some of you, but not to VanWinen. See, they're not like most construction companies. Now, but, like many of you, they were concerned that after the last downturn, the 2% profits they were chasing wasn't something that could sustain them. So they looked beyond their profession into how the makers of cars, airplanes, and software made their products. Now, VanWinen knew that their properties were at the opposite end of the spectrum of these products, but VanWinen was building lots of one-offs, right? Each one virtually identical, but each one custom-made. So they started thinking a lot more like an automotive manufacturer and developed a modular system for their housing components that could be used in many different configurations. And having invested in this catalog of component parts, they figured out how to build their components better. They figured out how to prefabricate each component themselves, first at their own factory, and then at any job site. And by 2015, all of their houses could be constructed on site in just 3 days. They flipped the very way they approach building houses. And now, they're looking to flip the very way they designed them too. So our teams met last year, and we compared notes. We were using our Toronto office as a living experiment to pilot generative design. And so VanWinen was interested in this too. So we helped them use generative design on one of their projects to explore 15,000 different design options. They focused on 3 of the most interesting choices that they could shape into the perfect urban neighborhood. Now, generative design helped them look across multiple dimensions all at once. They were able to optimize for backyard size and views to give the customers and occupants bigger gardens and better sight lines, as well as maximizing the amount of energy that they could collect. Generative design helped VanWinen meet their net zero energy goals. Not only this, it helps ensure that their housing met the human needs of their occupants too. But that isn't all VanWinen was actually trying to optimize for. Cost and profit were also part of the model. They're running a business after all. So reconciling goals that appear to conflict is something that generative design is particularly good at. So rather than follow a recipe for how they approach design build, generative design allowed VanWinen to incorporate reason into how it reconciles the affordable and the livable, the sustainable and the profitable. Data is transforming the tools that we use to design and build things. But as we capture increasing amounts of data, our traditional tools struggle to scale. So do we. But now we can tackle ever bigger problems because of 2 things: the capability of modern machine learning and the massive parallelism of computing that they run on. Take the problem of navigation, for instance. We all used to use our Garmins and our TomToms for directions, right? And then these things came along. So did Google Maps with its geospatial data sets that were patchy at best. But then all of us somehow came to rely on Google Maps. How did this happen? Well, several years ago, Google published sets of house numbers captured by Street View for analysis by humans. So hands up if any of you have ever created a reCAPTCHA prompt. Well, guess what? You were one of those humans. You helped Google Maps become more accurate. But you also helped build a training data for Google's AI, which was able to take what it had learned from you and apply it to street names. The AI models were able to read sets of ambiguous and poorly captured street names to a level comparable with human accuracy. So the maps grew more accurate as a result, and the data and the sophisticated AI, but the real transformation with those Google Maps now gave us the ability to look at what-if scenarios, to look beyond directions, to look ahead in time, and to make our decisions based on insight. Google Maps doesn't just rely on formulas and functions. It has transcended the conditional. It's moved from if-then to what-if. And from the data has emerged a more insightful tool. So what might our future tools look like transformed by AI? Well, it may be some time before we get to self-driving everything, okay? But what do the first steps look like? Well, let's start with BIM 360, which is our suite of tools that bridge the gap between what is designed and what is actually built. It does this by giving those working on the job site efficient and easy to use tools to contribute back to the building information model. Now, this means that contractors can benefit from the detail held in the digital models while building a much more detailed and much more accurate asset model for operations. But the data from this construction site is also transforming BIM 360 into something more insightful. We call it Project IQ. IQ takes 10 years of data, that's 27 million documented issues, and it uses AI to predict high-risk issues, project subcontractor risk, and to keep its site managers productive. The site managers at Swinnerton used IQ to check potential risks on their projects just like they check on a weather forecast. Now, we started by automating classification of the construction issues from the descriptions that were typed on site. So it's like autocomplete for the construction site. But now we've moved IQ onto image analysis and deriving descriptions and classifications directly from photos that were taken on site. So the system can reason that a picture of a sill that's damp underneath is likely a water leak from a poorly fitted window. It reasons that a scaffold with missing guardrails is a potential security risk. And what about subcontractor risk? If a subcontractor had a poor record on large-scale projects, wouldn't you want to know? Well, IQ looks into future for insights that can help those solve difficult scenarios. So it's like Waze flagging a pothole while you drive. You don't have to personally experience the pothole to know it's there. IQ's risk prediction model identifies patterns across vast amounts of historical data. But instead of using this data in a rear view mirror, IQ uses this data to help us look forwards. And rather than having the commodity and the conformity of a project plan dictate your approach to the world of construction, the data of IQ is allowing you to approach and adapt to the variability of the world. So we're helping unlock insights with the imagery and data already being captured on site. Today, IQ uses these patterns and this data to look forwards and to give the managers insights that they need to make just-in-time adjustments to their projects. But what if our tools could not look only forwards, but out into the world? They transcend today's just-in-time tools. If our tools could take real-time inputs from what they see in GPS data, weather data, and maybe even eventually actuarial data, just think about how much more they'll learn about tomorrow. As what we can do on our phones moves ever closer to what we can do in the cloud, our tools will take all of these real-time inputs and use them to extract insight from their environment and from us. They'll move from just-in-time to real-time. So no longer will we have to find our place in the BIM model. With our tools in our pockets, we'll be able to use augmented reality, things like this, and we'll always be geolocated in it. Rather than thinking of working in the model, rather than working on the model, we'll be working in the model. We'll be able to see our work and everyone's work in context to the real world. And so we'll spend a lot less time worrying about how certain components fit together and instead worry about how everything fits together. Now, we're already thinking about how AI can use and combine and look at how everything can fit together. This is the design graph, and it's an intelligent tool that learns how to categorize and manage components and our models. We're feeding it algorithms and huge amounts of 3D model data so that they can learn not only what makes a component unique, or what makes a bolt, or how a bolt connects to a washer, but how that bolt connects to the entire design space. And today, Design Graph can grasp the essence of the designs that we work on every day. So imagine what it can do when it starts to understand not just our components, but our contractors, not just our parts, but our people and our processes. We're going to be spending a lot less time on construction details and more time on important details. Our tools can take us beyond real time. In the future, we'll be able to explore scenarios in the digital world that haven't been explored yet. We all know how valuable simulation is today. Just imagine what it would be like to simulate an entire construction site in real time. We'll be able to explore every possible scenario from fabrication to occupation. So the best simulation code is effectively a model that calculates real-world performance. And by teaching AI and subjecting it to many inputs, we'll enable it to work not by calculation, but by intuition. So just as we need to let go of the wheel to fully realize self-driving cars, we're going to need to let go of our traditional tools. And only then will we see their true potential. See, our traditional tools were designed using logic, and it requires us that same kind of logic to operate them. Our tools exhibit logical characteristics like you see here on the left. We directed the tools that were often somewhat rigid and inflexible. But fueled by data, they've started to transform into something much bigger. And it's transformation like this that's leading to adoption of a more fluid and creative characteristics that you see here on the right. What's emerging from this transformation is something greater than the sum of all of these parts. Tools capable of representing and comprehending what we design, our ideas. And the means of giving these ideas agency and embodiment in the physical world, so that not only are we starting to share the same mindset as our tools, now thanks to VR, AR, machine learning, robotics, and new ways of automation, we can share the same experiences too. We can let go of the tool and we can let it come to us. And in doing so, we find not only our tools are just as logical and analytical as ever, but now they're also creative and intuitive. At Autodesk, we're designing these tools, and we're imbuing them with the qualities of a true design partner. A partner which is not just good at execution, but excels at exploration too. Together, we can bring out the best in each other. Together, we can make anything. Thank you.
Thank you, Brian. That was amazing and very inspirational. We have a few questions from the audience. Let's start with what opportunities do you see to automate the transition of data created in design and construct phases to projects, to operations, and how that creates a feedback loop to change how we design in the future?
So let me, one of the things I think of creating data and automating that towards from a project information model to an asset information model. And some of the things that we're looking at today is how to use things like object recognition to extract semantics data, right? So self-driving cars, they can recognize objects like people, places, correlation, traffic data, and they can avoid different distractions. I think the same thing applies, and one of the examples that we showed with Design Graph is we're already using object recognition data, not just to recognize objects, but the semantic of that object, that bolt, how it connects to the design space. So one of the opportunities I really see with this is being able to extract things from the construction site semantically, and then to be able to automate that back into the digital model, right? And so we're looking at that, we're doing research around that, and I think that's where you remove a lot of those, minute tasks that are required to keep models updated and look at ways to automate that by using insights from humans, insights from AI, and insights from all of the built environment around us.
So basically, as a minimum, have the as-builts kind of build themselves.
Ideally, yes.
Okay,
yes.
okay. What are the biggest opportunities for the construction industry to learn from peer industries and catch up? We have a general sense of being behind manufacturing, healthcare. What are some of the things we ought to focus on first?
I gave an example of that, I think, with what VanWinen was doing, right? And what they did is they looked at adjacent industries. I think there's a huge, I mean, you're seeing a convergence today of manufacturing and construction, but it's also going to change. Manufacturing won't look like where it is today. I think looking at a lot of these adjacent areas and finding places that you can adopt, so what VanWinen did to prefabricate their components, to create a modular system of components that they could prefabricate and to discover new products from that. So I think a lot of it is in looking at those other industries and adopting things that might be relevant for where you can go today, like prefabrication.
So you described how they were moving into their design. Are they yet using bots to interact with structural analysis, pipe analysis, rather than the humans having to be that connection point?
So I was going to ask for clarification. Bots like robots or
just automated entities. Basically, you know, the human says, I've got structural steel, it needs to do this, this, and this, and the machine goes in and grabs whatever analysis algorithms it needs and brings back the answer.
Definitely. I mean, we call that cobots, like collaborative bots, right, or robots that collaborate with you. And there is going to be, you know, a lot of people are scared today about AIs taking over and robotics taking over, and I don't see it that way. We're going to merge, and we understand machines, we understand humans. It's the plus. What's the plus, right? And what's the plus between machines and humans and AI? And so having this relationship where humans can instrument some of the harder problems and take those decisions. I use an example like that with the urban neighborhoods where we simulated 15,000 different designs. We allowed humans to kind of vet the ultimate decisions. Same thing could be with robots.
Okay. Advanced work packaging is a CII best practice and has been a big topic of conversation yesterday, and going forward we have a CBA around it. Are there ways that people are breaking up and putting their work packages together using AI to kind of describe how they're going to go about parceling out the work on a construction site? Because coordination among crafts is a big aspect of it, right? They're all trying to work in the same physical space. So is actual AI helping, or are the humans still having to use the tools? I mean, in a best case scenario, they have enough data to put things into packages, right? But optimizing what goes in each package and optimizing the order of the package, what are you seeing in that area?
I think not as much in construction as we'd like to see, but I think there's a lot of these other industries like manufacturing that are really doing that. And I think those are things that we can start to learn and adopt from. I have this kind of thing that there's going to be less specialization and more transdisciplinary tasks, and there's going to be a lot more collaboration between robots and extracting insights from humans and then using that in different systems. So,
okay.
Yeah.
All right, so adapting generative design to industrial spaces, we're still mentally, a lot of people are still in the every plant is a snowflake, right? And we've got people that are talking about that. I mean, we talked about it yesterday. But clearly you kind of have to reorient yourself to look for ways where it's not always unique, right? I mean, that was what that building company did. And so describe just a little bit generative design in terms of the inputs that it requires, the underlying data that it needs, because I think another part of our problem is that we're still, a lot of our data is locked into things that are more like ore and less like oil, and we're having a little trouble mining that out and getting it into a fluid state that we can do some of these things with.
So, I guess I would answer the essence of what generative design is it's not about, it's about specifying goals and constraints around a design, right? So, very simple example, if I was designing a chair, I'd have a load on the chair, I'd have the structural, source, I'd have a density and a mass and a volume. I'd let the AI system then figure out all the rest, right? Because I can use all of that computing power in the cloud to simulate tens of thousands of designs with simulation on top, right? In the time it would take me to do one. So by really starting to think about and abstracting what are the goals? What are you trying to do from a goal perspective? Maybe not from that little minuscule. That's really what generative design is about. It's about applying goals to a design. Now, do we have every type of option of doing generative design today? No, we're looking at that and we're applying different solvers. So like there's simulation solvers that we work within that and what we did with our Mars project. But that's all going to keep expanding. And I think the real opportunity in generative design for all of you to think about is what are your goals? What are your real goals on a project and how do those apply to the bottom line?
Are you seeing people who had historically said, I can never go to the cloud, my IT people won't let me go to the cloud, my regulators won't let me go to the cloud, all this stuff sounds great, but I can't partake because my organization won't let me. How are we going to overcome that and how are people dealing with that?
Yeah. I think in the enterprise space, it's still coming up, but I'll just say this, right? And I'm going to just bear with me. If I was going to give you guys a device, 10 or 15 years ago, and I said, okay, wear this device. It's going to know everything you do, where you go, who you talk to, what you search. Would you wear that device? Would anybody, raise your hand if you would have said yes, right?
Yeah.
Now we line up at the Apple store for those devices. Why? Because they give us convenience. The data that we give up into that cloud, right, isn't as valuable as the convenience that we get back from the insights of that data. So the thing I'm really excited about is, there's definitely IP. We care. There's governments. There's a lot of stuff we don't want people to see. I completely understand that. But you need to think about what data should you keep and what data should you let go to benefit not just yourself, but all your companies and ultimately society. I think that's a real powerful thing. So that's how I would answer that question.
Okay, and what do you see as the barriers to being able to do this, and how do you incentivize crafts, skilled labor, your own management to embrace? I mean, it's similar to what you just answered, but
Sure.
Are you seeing some really good examples of how organizationally people have changed incentive programs in order to get this thing moving?
Yeah. I think a lot of it's education. I mean, I think definitely it's going to be about educating. I think it's also about starting and understanding it, taking from a KPI perspective, whether it's an upper end KPI or a lower end KPI, and driving it from that. I can't say it enough. There's so many people excited about technology, but technology isn't going to change. What's going to change is how you apply it. Okay, and if you understand what your real core business challenges are, there's lots of really smart people in research. I'm seeing people in this group that can help you solve that problem, but it's defining what are you trying to do first, and I think that's really important.
So talk about the approach to creating training data and just data sets generally to really make machine learning go, because that also has been elusive. We don't consider ourselves to have the kind of large data sets that a Google or a Facebook have.
Yeah.
So how is the construction industry going to get enough data in play to do machine learning on it?
Yeah. I would say there's a ton of sensors we're already seeing being instrumented on a construction site. We've got cameras, there's vision systems. I mean, there's a whole variety of opportunities that is already, there's a ton of data being captured on construction sites. The question is, are you leveraging it? What are you doing with that data, right? And I think that there's a big opportunity to do a lot more. And if you can apply machine learning to that, then you can recognize patterns in that data and you can see things that maybe you might not have ever seen.
So I haven't read whatever the Facebook headline is this morning, but there are several questions along the lines of self-driving cars and somebody dies and how does the liability work and what happens when the data gets out and about where it's not supposed to be. What is Autodesk thinking in terms of how data needs to be secured, how data You know what I mean?
Yeah.
How do we deal with the fact that these bots are going to have troubles just like the humans have troubles?
Yeah, so I mean, we take data extremely serious. I mean, everything from security, penetration testing, all of that. But I guess what was the other part of the question was?
So there are going to be, this is still in our industry, there's still a lot of skepticism, right?
Yeah.
There's a lot of people who aren't ready for the free-flowing, you know, we're just a little bit conservative in this industry. Sure. Just a smidge, right? And I feel like there's going to be a need to address some of this, you know, the show me thing, like what is going to happen, right? I remember being at a future tech thing that ENR did, and the California guys were out there telling me all about these self-driving cars and the cameras on them, and I'm like, okay, you're in San Francisco, I'm in Kansas, it snows. When it snows, the little lines on the road aren't there. What are your cameras gonna do, right? And so there's a lot of practicalities associated with this, right? And so other industries have gotten the practicalities up, they've dealt with them, they've moved on. So what do we need to do as an industry to surface these things, address them so that we can move on?
Yeah, I mean, one of the things from self-driving car perspective, we need a lot more regulation with AI. I mean, I'm just gonna say that I don't think AI can be going out fully unregulated. I mean, if you look at, you know, Uber cars in Phoenix, they don't even, there's no regulation. You can just get a registration of a vehicle and have a driver safety act behind that. So my answer is pretty much purely how we regulate. I don't think we should be scared. I think what we should do is embrace it, but we need to think about how we regulate it. And that's where I think a lot of this is gonna come to play.
So with that company that does the building generatively, somebody still has to do what we call the PE stamp, the professional engineer stamp, right?
Yes,
A human still has to put their mark on it and say, yea, verily, I approve this thing, right? So how are you seeing that manifest itself in terms of certifying, in terms of QA checking, in terms of knowing how the bot did what the bot did, that kind of thing?
Yeah, the Mars project that we had, we had to work with all of that, right? I mean, Canada's actually probably got even harder standards in some respects than we had here in the US. So we definitely had to have that stamp. That was part of that whole process. And how we work with that is, again, it's a goal-based system, right? So you can set goals that are related to to standards too, or to what you need to do within that space. A lot of it was too also working really closely with those bodies that manage that space of the Mars building and all of that.
One of the things that I feel is going to be different for us, we all have been involved in systems where we carefully programmed in the equations. We figured out what the equations were, we programmed in the equations, we knew what the equations were, we validated that the results met the equations. Generative design isn't like that so much, right? You let the computer figure out the equations. And so how is that going to, how do we go about actually starting something like that, right? Do you give it data and let it figure stuff out? How do you begin from a data perspective? So
from a data perspective, I mean, to be clear, we're not like letting generative design and AI solve a new way of doing simulation that we've done really well to figure load bearing. So I would say we're using those solvers in the process of generative design. And so we're
not really letting it invent its own solvers quite yet.
Not quite yet, but what we're doing is we're using those solvers, right, to specify goals and then like to simulate things and then to find lots and lots of alternatives. And so the real opportunity is this huge alternative space and then being able to narrow it down, right? And I think that's the real goal of all of this. And I don't want to postulate that we're going to start making up all sorts of new solvers and stuff that really works well. We want to apply the stuff that works well to generative design.
Okay, but you have shown that the design that the computer comes up with is different, and that I mean, part of what you showed was the additive manufacturing.
Yeah.
And the designs that you can do with additive manufacturing aren't the same as the ones that you have to do with subtractive manufacturing.
We're getting really close. Actually, we've done some amazing advances with Subtractive. One of our projects, Dreamcatcher, the topologies are very, very not common, not straight. And so we're using AI and also to figure out tool pathing, right, for doing Subtractive. And I'm not going to claim to you all that we have everything figured out. What I want to say is that there's some really radical, amazing innovations going on out there today in different industries, and we're proving points of value. We're proving points of this. I mean, the Mars building was a serious project. VanWinen was a serious project. The VAMA 12 plant in Norway was a serious project. Those are all applied in the built environment, not as a pilot, but to actually make something happen. We still can learn more, though. I mean, we're still going to keep learning, and that's what we're always about, is learning from our customers and learning from the industry and where you guys see things going and how we can get better with it.
So what are you seeing in any industry in terms of the people that apply these new ways of doing things and the market share that they end up with because they're able to do things more effectively and they drive other people out of the industry?
It's awesome. But I'll say, great example. So, NASA and SpaceX, If you look at what SpaceX has been doing, and how they've revolutionized payloads and rocket and the cost of building rockets, it's flipped everything on its head. I think the Falcon Heavy is the biggest payload at the cheapest cost of whatever NASA's cheapest rocket was. So that's the real step change. The step change is as soon as you start thinking differently, you have the potential to upend and create true competitive separation, maybe even radical competitive separation. And I think that that's a really exciting thing that we have today that we can leverage.
Okay. Let's see here. I'm carefully moderating my questions, as some of you are all about the bad things that happen, right?
Well, throw me a bad thing.
Okay, so apparently
whatever.
A driverless Uber car killed a woman
Yeah.
walking her bike yesterday.
Yep.
What
Phoenix.
do we do about that?
A perfect example of regulation. So I just mentioned this, Phoenix has no regulatory on self-driving other than you put a human behind the wheel. Shame on them.
So basically
right?
that
so you need
woman's
regulation.
family can't sue that driver, or she'll end up suing somebody, right?
I feel terrible for that. The other thing I think about that, and this is a thing when I was reading the article, is that location where it happened was a 6-lane into a 4-lane, where there was no really insight to pedestrians or walkers crossing. Maybe that was a I'm not going to, I don't know what it was, but if you regulate it and you could watch and you can understand how are they capturing this data, what are they doing with this data for self-driving, that's going to make the systems better. So it's not dystopian in the fact that, there's going to be accidents, right? But you have to regulate, right? If you don't regulate,
kind of no different than we did when we regulated what steel workers had to have in the way of safety, or anything else that we've regulated for humans. We're going to have to catch up with that with these AI. All right, so we've got just a few more minutes, and I'm thinking about questions along the lines of just getting started, I guess. What if you were going back to your company and you were gonna call everybody together and say, I'm pretty sure we're in deep sewage because somebody's gonna figure out how to automate this stuff and we're not working on it yet, what should we do? So how do people begin?
I would recommend starting small. I think it's important to not try to boil the ocean. I think it's also important to try to figure out what you'd like to do. What are the most important parts from a KPI perspective, right? Okay. And then start to try things. I can't say enough with innovation space. People think that, I gotta wait to do this, it's gotta be perfect. There's no, if you have small teams that are doing innovation or you're just trying to do really small tests, there's no big risk in that. And what that helps you do is it gains confidence, but it also helps you understand the technology or the application of the technology better, and then hopefully, ultimately, it can kind of break into insights on how you would further apply that. So I would say start small, but also before you start with technology, start with the business drivers. Start with the business problems that you really want to try, and then start looking out, because there's a lot of people out there that are broadcasting all of these great things that might be adjacent, but actually could be leveraged, like I showed.
So do some research.
Yeah.
Okay. All right. Well, I'd like to thank Brian Pene again, and we'll thank you very much.